Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things Substrates, Polkadot, and Web3. Today on Relay Chain, we have Alain Brenzikofer from Encointer and Supercomputing Systems. Can you give yourself an introduction, Alain?
Yeah, sure. Thanks for having me here. I'm department head of decentralized systems at Supercomputing Systems, where we focus on, let's say, blockchain, especially in the energy sector, but not only. And I'm also the founder of Encointer.org. And I'm happy to talk about these two activities today.
So can you give a brief introduction to Encointer, because you just put out a really quick demo online?
Yeah, okay. So the goal of Encointer is to give a basic income in cryptocurrency to all humans. By doing that, also giving them a digital ID. So we actually need both. The project actually came up because I wasn't very happy with what I saw in this field. It was always like some early adopter bonus and deflationary monetary system and all, where I just realized that it's not how I would imagine a revolutionary monetary system. Because, at least not if you have a more social goal. And on the technical side, I wasn't very happy with, especially proof of work and its wastefulness with energy. So I kind of looked at everything that was there and how I thought it could be done differently, and that's now Encointer. So yeah, that's the basic idea. And if we want to give a basic income to every human, there's a few problems we need to solve at first. And one is we only want to give this income to humans, and we also want to be sure that every human gets the income exactly once and not several times. When I thought about this problem, I was chatting on forums and nothing really convinced me until one day there was this idea of a person can only be in one place at one time, and why not leverage this to make sure a person can only get one ID. And that's how this whole ceremony idea came up, where at the same time all over the world, or at least per time zone, people would meet in randomized groups of, let's say, 3 to 12 people and attest each other's personhood. So they just meet, and if you have a human opposite, you always know it's a human, so you can attest that. You don't need to know the name or whatever. You don't need to know anything about this person, but you can be sure it's a person. And these key signing parties were at the core of the idea of Encointer.
Yeah, so there's a lot of pieces there. There's the identity, the universal basic income, the blockchain part. Just to go back to the universal basic income as kind of a response to the sort of VC model of cryptocurrency where the early adopters get a huge percentage. What was your motivation there? And how do you model universal basic income differently, so that the people who join later can still get fair benefits?
Okay. So the way the basic income works is you have these ceremonies every 41 days. Well, this number is completely arbitrary, but it's just something, an odd number, so that it's not always the same day of the month or something like that, or the same day of the week. So at every ceremony, you have the chance to participate. And if you participate, then you get money issued on your account in return. So let's, for simplicity, say it's one Encointer that you get for every ceremony. Now, the token design with this rule is actually that it's inflationary, and it's inflationary to the rate of adoption of Encointer, because if you have more people joining, then more money will be issued. So this way, we can make sure that that there's no bonus for the first ones who are there, because you always get one coin, and there's no reason because the money supply is not capped. It's scarce in the sense of you know the rules of money supply, but the monetary base only grows with adoption. Well, on one hand, that's a kind of a stupid idea because it won't make me rich. But that's kind of by design. And the question there is how will this currency gain value, of course, because it is very inflationary in the sense of nominal, because every month there will be a new issuance, but that inflation is actually linear. So if the population of users stays the same, then you have a linear inflation, and the relative inflation rate will go down over time.
Yeah, so it has value in the sense that there's an actual human being that can account for it.
Well, I'm not sure if that's enough to give this currency value, or well, most probably it's not. I think the value will come from its usefulness, because other cryptocurrencies now, there's one thing which is special about Encointer is that I'm not intending to have like transaction-based fees. I want to have proportional fees. That means there is no issue with micropayments like in developing countries, for example. Because if you look at the transaction fees of Bitcoin and Ether as well, the transaction fees can be as high as a day's income or even worse. So I think the usefulness of Encointer for these places could just be to have digital cash, which is a lot more usable than the cash issued by these countries. Because if you are in a very rural place in a developing country, usually you have a hard time buying some little stuff, because you come there with like big bills as a tourist, for example. that's what I experienced, and then they have to run across the whole place to find change. So there's a real practical value of having digital cash, and a lot of these people have phones, and soon will have smartphones, I guess. So that's a very convenient way to have money.
Before going like deeper into like the local currency stuff, how does an actual Encointer ceremony work? What do you do?
It all starts with registering. So you download an app. Right now there's only an Android app. And then you register on-chain in advance, so a few days or, well, at least 24 hours in advance. And with your registration, you say where you are and how far you are willing to travel for the next ceremony. And then an algorithm will take all these registrations and arrange these randomized groups, these meetups. When the meetups are assigned, then that algorithm also tells you where the intersection of all the acceptable regions are from the participants, and then the participants have to decide where exactly they are going to meet. Because that's not up to the algorithm to do, because it could suggest some private property or whatever, or in the middle of the lake, or I don't know, because the algorithm is not aware of the geography. So the participants agree on a place which is within a certain tolerance of what the algorithm says. And then on that day at high sun, and you need to be very, very punctual, you meet, and then you come with your mobile phone. The phones discover each other, and you have to enter how many people attend the meetup, because that's the first human trust factor that we have in there, that you see how many humans are present, because we don't want one person to bring two phones and have both attested. And then just pairwise, you sign each other's keys. And then you go back, and the next time you have internet connection, you can upload all these endorsements or key signatures from all the participants. And when the whole ceremony is over, there's that algorithm again, or another algorithm that checks if all these rules are fulfilled, and all the participants who participated in a legit meetup, they will get their rewards.
Yeah, and so these rewards, we talked about this before doing the podcast, but like it allows you to have local currencies. Also, like in addition to Encointer, you can create your own for a region. Can you just talk about that? Yeah,
well, as far as I know, it's a novelty in the cryptocurrency space to have the possibility to have currencies which have a geographical root, which we call seed. So if you meet somewhere, you have quite a good proof where this meetup took place, because at least you have all these participants with their GPS information on where it took place, and it's not so easy to spoof because it has been predetermined where about the meeting has to take place. Now, if you bootstrap the first meetup in your region, then your meetup location is the seed of that newly created currency, and all the meetups that will take place later in the vicinity will have the same seed. So whenever you have like an overlap of tolerance regions of the participants, they will all belong to the same seed. Now, of course, that only gives you an information about where the money was minted. So you can, of course, spend this money globally. There's no way to prevent that. But that's actually fine. It's the only problem that I'm, to be honest, haven't solved completely is now we have all these local currencies, and what should be the best rules if regions converge. So if you have two cities who start on their own and then suddenly they grow together, or people move from one place to the other, of course the rule set, the best rule set, is not yet written on how to find, because somehow you need to discover the price, or there needs to be a market. But when two regions grow together, probably there will be one seed which will win, which will take over the other. But then what do you do with all the money that has been minted before? And I mean, there is a rule set. We did simulations on what happens in that case, but I think there's a lot of work to be done there still.
I mean, wouldn't you start to get price stability just from like arbiters that would actually travel across these regions before the regions started to come together in a bigger sense?
If I get you right, I mean, we could enforce the rule that you cannot bootstrap from the beginning, so that kind of Encointer has to grow by people traveling and kind of bringing the message. But, well, I think that will be very slow adoption, and I'm not sure. I mean, the whole trust will improve with people traveling, because if people travel, they kind of can go verify if the other region complies with the rules. And so that's actually very desired.
So maybe I'm like not understanding it, but like after you get issued the currency at one of the ceremonies, you can still transfer it after, right?
Yes.
Yeah. So like, couldn't you go to a ceremony and then, drive to Geneva and sell it there? And then so you have like
you could.
a market.
Oh, yeah, you
but
could.
People could go the other way too.
Of course you could.
So like
you don't even need to travel, because you can. Yeah,
of course.
You can have exchanges online.
Maybe people want the physical money. I don't know.
Yeah.
So we're going to start to like transition a little bit to SCS. Mm-hmm. Unless there's more you want to cover on Encointer.
Of course, there's more I want to cover.
Oh, go ahead.
No, it's fine.
You're developing a SCS, a solution for trusted execution environment. How are those important for Encointer?
Well, if we have a digital identity by means of these ceremonies, then I want to be sure that people don't identify themselves if they attend to a meetup or if they spend their money later. So anonymity is a very important factor, especially for Encointer, because you're linking your physical presence to the money that is minted. So there's additional risk factors to this than for normally for cryptocurrencies, and even worse because in order to be sure that a person only maintains one identity, and Encointer has kind of a rating system on the identity. So if from the last 3 ceremonies you attended to 3 of them, then everyone can be sure that you don't maintain 2 identities, like alternating at each of these ceremonies. So your identity gets stronger and stronger the more you participate, and there is more profiling that can be done on you during that time. So
by using the same address?
Yes. Well, you're not using the same address because for Encointer you can use a different key pair for each ceremony where you attend, and then you can just later link these if you need.
Like with certificates.
Yeah. So we have a need for privacy also for spending the coins. So that's how this whole trusted execution idea came in, because I looked into like zero knowledge proofs, like Zcash does it, or ring signatures, and like Monero, and they all come at a price, and well, what we approach comes at the price as well. The price that we pay is we trust a hardware manufacturer to do the right, to do what is kind of written in the data sheet, so to say. So in our case, that's Intel SGX, and Intel can attest that a software is indeed running in a trusted execution environment. And well, maybe I should introduce what trusted execution environments are, because I think it's not yet common knowledge.
Yeah, I think we could probably do like a whole episode just on that.
Probably, but well, I'll try to do it in very simple terms. We are very used to the fact that whoever is administrator on a machine has full access to all the data in memory, on the disk, wherever, and can change this data and can change what programs are running. And if we have cloud systems, for example, which we trust, then we still trust the administrators of these cloud systems because they have full access as well. Now, what trusted execution environments do is they isolate certain processes in an enclave, which has its kind of private memory, which is encrypted. So from the operating system side, it's opaque. You don't see what is done in there, and that's ensured by hardware. And now that means you can do confidential processing in this enclave, and you also have a guarantee of integrity, because that hardware also tells you what the hash is of the binary which is running in this enclave. So you can cross-check with let's say an open source repository which can be built in a deterministic way. So you can check that the hash of the binary indeed in the end is the same which is running on the enclave. And now the missing bit is the remote attestation, because I could, if I'm a cloud provider, I could just tell you, yeah, I'm running SGX. Believe me, I can't see what you're doing, but that's not very convincing. So what Intel does is they have this attestation service that you can challenge an enclave and get a report from a quote from the enclave, which you can send to Intel, and they attest with their signature that the hardware is genuine, and they attest the hash of the binary which is running in that enclave. And now if this enclave can maintain its own key pairs, then you can talk to this enclave and be sure that the administrator of the machine cannot change anything or see anything.
Yeah, it's like the way I understand this, and you should correct me where I go wrong, but like even if you're keeping all of your information on disk encrypted, which you should, when you bring it into memory, you're going to decrypt it. And so you have decrypted information in memory. And the operating system, so other programs shouldn't have access to this, but the operating system does.
Yes,
and so
exactly.
The person who controls the operating system can get access to the information in memory, and this is just getting passed over the bus into the CPU. And in SGX, you're actually just copying encrypted information into memory and then sending this encrypted information to the SGX, and it's being decrypted in the actual processor, operated on, re-encrypted, and sent back to memory.
Absolutely. I mean, it's not only the administrator which we don't trust, because if an administrator has access, then all the malware which can get privilege can do the same. So that's the actual, or probably the bigger threat even.
Right. Yeah. Okay. So then the question comes like, why should we trust Intel with the attestation?
Yeah. I mean, that's a very valid question. And I mean, we have to trust the manufacturer, but at least we should have transparency on the hardware design. And that's what Intel doesn't offer. So we actually not only trust Intel that they give correct attestations, but we also trust them with like their hidden design, which they don't open for like scientific auditing. So the second problem is something where I hope we will see different solutions in the future, like for example Keystone, which is an open source T design, which doesn't exist in hardware as of yet. I don't know exactly where they are, but I hope that initiatives like this will sprout and also give us remote attestation.
Yeah, I mean we're already trusting Intel a lot. Right, like no SGX or SGX. So
I mean, it's the same with zero knowledge proofs. I mean, if you compute zero knowledge proofs on an Intel CPU, you already trust Intel,
right?
Because if there's a backdoor, there's a backdoor, and yeah.
Yeah. Okay. So if we just take it for granted that we trust Intel here, and that TEs provide an advantage in privacy or confidentiality, so can you talk about Substrate-TE and
yes.
what that is?
So now that we have T's as a tool, how can we apply this to blockchain? There are different ways how you could do that. You could run your entire node inside a T, or you could use the T just as a wallet, for example. So as a key store. The way we thought it makes the most sense is to use the T as a trusted off-chain computer. So what we do is we take a smart contract or a business logic off the chain and put this code into a T, and then we just make sure the whole chain of trust is ensured. So how this works is you may have a machine which features SGX and you want to be a SubstraTEE worker. What you do is you register on the SubstraTEE chain and you supply an attestation from Intel. So if you do so, you need to get a license with Intel, but at least the users don't have to. So only the ones who run the worker have to. Then the chain, the SubstraTEE chain, can verify the attestation by Intel. And if you qualify, then you are registered with your signing key. And then from then on, you have a public register of a worker, and the user can come and say, okay, I wanna perform this task on that worker, and can then ask the worker for its shielding key. And well, now now it gets a little tricky. So because we want to send requests to the chain, so we do indirect invocations in order to order transactions. So if you want to call some smart contract, you write the call and you encrypt it with a shielding key because we don't want anyone else to know what the call is about. You send that encrypted call to the chain, to the SubstraTEE chain, which then forwards it to all the workers. The workers can then decrypt the request because they own the shielding key, and then they process whatever state transition function you have defined previously. Then once the request has been processed, the worker writes a receipt back to the chain, which says the request with hash such and such has been processed. And that's written back to the chain, so everyone who needs to know can look up in the chain if the request has been processed.
Yeah, so it's like the entire state encrypted?
Yes. So the state is entirely off-chain. So it has nothing to do with on-chain state. It's a completely different state. The state, of course, is encrypted. And the encryption key is something that all the workers need to share. Because if you join the set of workers at a later state, how would you bootstrap unless you have this decryption key? So the way we envision this is, or we implemented it actually, is the first worker initializes the state and just creates a new encryption key for that state. It then shares that encrypted state over IPFS, and if another worker joins the set, that worker will ask the first one for like giving him all the keys needed. And there is a protocol to that, of course, to ensure that it's actually legit SGX enclaves talking to each other, and that's called mutual remote attestation. So the two workers have to attest to each other that they are genuine SGX enclaves, and if that succeeded, then the first worker can send the encryption keys to the new worker. The new worker can get the encrypted state, the most recent version from IPFS. And the way this works is with every receipt a worker writes on-chain, you also send the IPFS hash of the latest state. So this way you can always be sure that everyone is working on the same state.
Yeah, so how often do you get these attestations from Intel? Is it like every block, or is it just once when you join?
No, well, actually you could just require this when you sign up, but then there's a problem if there are always over time security vulnerabilities in SGX which are discovered, some of them more severe, some of them less severe. But what Intel does with remote attestation, they also check if you have the latest patch applied. So that means we should actually require regular remote attestation for the registry just to make sure that people apply the latest security patches from Intel.
Yeah, okay. I was wondering because if it was like every block and you have 1,000 workers or something, then it's like it slows it down because everybody's trying to request.
Of course. No. I think once per day should be fine. But,
okay.
I mean, yeah.
So it's not like it's not on the critical path to every block or anything like that.
No, it's not. Not
okay.
at all. No.
If we
and, I mean, if it would be, that would be like absolutely fatal, because that would mean Intel could shut down the system.
Yeah, right.
By just rejecting attestations. And that's why I think the combination of blockchain and trusted execution is actually a very good synergy, because if Intel rejects to attest someone, because they always know who is asking for an attestation, and they could just ban you. But if we have a blockchain, then at least we have a remote attestation, maybe not a very recent one, but we are not. We can continue working with the system with, let's say, reasonable trust for a while, even if Intel bans that worker.
Yeah, enough to get a new worker or something.
That probably wouldn't help, because if you wanna run the thing in production mode, then you need a commercial license with Intel, and you can only get that as a legal entity, and so it's kind of, I would say, low entry, but still there's some paperwork to do. So you cannot just come up with a new worker and be a new identity for Intel. That doesn't work.
Sure. So yeah, if we back up onto the just blockchain and SGX thing more in general, like you mentioned in one of your presentations that this helps solve confidentiality, scalability, and interoperability.
Yeah.
Can you talk about the target user base and who would be using this, and then how this helps?
Yeah. Maybe first, so far we only talked about confidentiality. So I think that is interesting for enterprise use cases which have to comply with GDPR, or which don't want to share their company secrets, processes, data, whatever. Of course, I'm not a lawyer. I cannot guarantee that with SubstraTEE you absolutely comply with GDPR. But I mean, what we give you is that you store no personal information on chain. So you can do things like you can implement a right to erasure within your enclave. So that's kind of the target. Apart from Encointer, I think it will be businesses who have to comply with GDPR and such, which will be interested in this solution. But then there's also scalability, and that's work to be done in the future, because as I said before, we have indirect invocation right now, so you always have to send your request to the blockchain, which will then forward the request to the worker, which will then in return write a receipt to the chain. So that's not a very efficient way to do it, because you need several on-chain transactions for just one request. The way we could also do it is by direct invocation. So that means that we only use the blockchain as a registry for workers, and then you can talk to the workers directly. However, the problem that we need to solve there is the ordering of transactions. So there is a little bit of centralization there, because we need to, well, either we have an entire consensus system there, and then we can go to the blockchain in the first place, or we just sacrifice a little bit of decentralization by just saying we have somehow round robin rule for the workers to process requests, and then you just talk directly to these workers.
Yeah, so you see a Substrate-TE chain being run as a generalized chain, or everybody can put their application on it, or would you see more you have an application that wants to use this, and so you'd integrate as this Substrate-TE off-chain worker part into your own chain?
I think SubstraTEE will more be just a platform or a tool that projects can use to build on. I don't think there will be kind of the public SubstraTEE chain where all the enclaves register. I think it makes a lot more sense that you do that per use case. Yeah. Because anyway, with Polkadot, you have the root of trust of the relay chain, so there is no point in focusing on a single SubstraTEE chain, because that would just limit scalability.
Yeah, so it's a tool that you can integrate into other chains.
Of course. Well. I mean, basically, it's just one custom module to a substrate chain.
Oh, okay.
Yeah. We don't need to go into the very details. We needed to patch some things in Substrate to get the host calls in order to verify the Intel attestations, because that's not something which is already supported by all these libraries.
Right.
But I mean, Substrate is getting more and more generic, and I think in a few weeks or months it will be a plain Substrate with just custom modules.
Yeah, it's really getting close to that.
Yeah.
So you mentioned in the same presentation this trade-off between integrity and confidentiality, that like as the number of nodes goes up, the confidentiality decreases because there's a risk of somebody leaking the keys, but the integrity goes up because of what most people in blockchain already know, that you have more copies. Like, how do you look at that trade-off?
Well, in the end, what we would like to have is a diversification of T's. So, but that is more a mitigation for integrity. If we have different technologies all running the same state transition function, then the integrity is improved, because if one of the T implementations is flawed, then it will be outvoted by the other ones. However, this is actually even worse for confidentiality, because you have 3 implementations and you only need one of them to have a vulnerability in order to leak the state. So I think in the end it's up to the very use case to decide if you want to focus on just one technology of T's, or if you want to diversify, or I think that's not a decision for us to take. We can just provide a tool that lets you like move your focus in that regard.
Yeah, but that fits into like the modularization of Substrate, and that like you can, if Substrate-TE is like a module that you can just plug in, then you get those options, and like
that's the goal. That's the goal. It should be just kind of something you can plug in, and that's also. I mean, even for Substrate, there's now these Ink smart contracts, and we did a little proof of concept, and we could very well run these Ink contracts in our enclave. So actually, the decision by a project can be, well, okay, let's start with like usual Ink contracts, and then once we're done, we think they work how they should, then we can just instantiate that contract in SubstraTEE, and you get can kind of plug in confidentiality.
What changes like at the coding level when you're programming for SGX or TEE? Because like most people, when they're programming, they're not really thinking of like what's the processor actually doing. Like how do you have to change your paradigm in order to do that?
Well, of course, it's a bit more challenging in the sense of you need to be very aware of what you're doing and what can happen if a program panics, or if like something unforeseen happens. But basically, we are building on the Rust SGX SDK, which is an Apache project by now, which gives you the environment to just basically write Rust code, and it should more or less run in the enclave. The difficult thing there is that you have no standard library at your disposal, or at least not the standard library. So there's a replacement for that by that SDK. So not all the Rust libraries will just work out of the box. Okay. So that's kind of, I think that's what we wasted most time on in the process.
Replacing the standard library stuff.
Yeah. And kind of upstream pull requests and
Okay. So like what's the current state of Substrate-TE, and then like what's next on your roadmap?
The current state is we have an implementation of private token transactions. So we instantiated the very standard balances module from Substrate inside SubstraTEE, and we have an example which you can try out in a Docker container. You can just try it out yourself, even if you don't have an SGX hardware. You can just run it in software mode. And this example just shows how you could have a confidential ledger with balances that you can transfer at will from one account to the other. The next step will be that to link on-chain state with off-chain state. Because right now, with what we have now, you have no possibility to have a trusted read of on-chain state. You could, of course, have some call out of the enclave, some RPC call to just query the state, but you have no no guarantee whatsoever if you are told the truth. And the next step is to verify inclusion proofs, to have read proofs. Substrate has already implemented all of this in their light client, and all we have to do is actually instantiate that light client inside an enclave and just do queries as if an entire light client would be running in the enclave, and then we have trusted access to chain state and to inclusion proofs, and
Yeah. Is there anything else you want to add to SubstrateTE or Encointer?
No, I think we covered the most important things.
All right. Where should people go look up to get more information?
Of course. Well, it's all on GitHub. You can go to encointer.org. There's a few blogs on how we envision like the whole economy to work, how we envision this to change the way development aid could be applied, and what it does to like the whole digital identity sphere. So I think that's a good place to go. And SubstraTEE, you can just find that on GitHub and play with the Docker demos, and we're always open for feedback.
All right, great. We'll put some links in the notes. Thanks for coming on, Alain.
Thanks for having me.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter at RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io/newsletter.